Currently, more and more scientific papers are being published devoted to the development of methods to reduce and control energy consumption. Opinions of scientists differ. Some scientists insist on increased their requirements to the level of thermal insulation of building envelopes, while others consider the existing regulatory requirements excessive. The third group of scientists offers the optimized models in which a number of economic and ecological requirements are balanced. It is known that about 15% of heat losses fall on the walls of apartment buildings. Therefore, the impact on energy consumption cannot be underestimated. Improving the energy efficiency of building envelopes of resident buildings are achieved by application of effective heat insulation in constructions of external walls, coatings, flooring, and partition walls. Energy saving measures to insulate the facade of apartment buildings are promising and guarantee significant savings of heat energy, and as consequence leads to a decrease in the volume of consumptions of public utilities. When analyzing the energy efficiency of certain building constructions, one of the important factors is climatic indicators. It can be noted that the thermal and technical characteristics can vary significantly within the same city. Thus, summary in this scientific paper considers the impact of climate change on the payback of additional insulation. As a result of studies done by the author noted that such measure as increasing the thermal insulation properties of building envelopes does not always lead to a positive result. This pattern is associated primarily with the climatic features of a particular area, which are not always taken into account when carrying out thermal modernization of buildings. After all, saving thermal energy is a promising field of energy efficiency. If we consider traditional facades, they cannot fully respond to changing thermal and light conditions in the environment to improve the internal environment because they are static systems. Thus, the ability of dynamic control and management of energy efficiency is limited. With the advent of innovative technologies, buildings with kinetic facades, which can change their appearance depending on the environment, are becoming more and more promising. Consider more advanced building envelopes in terms of energy efficiency. Adaptive energy efficient systems. These systems are designed to respond dynamically to change in the surrounding climatic conditions, which implies better efficiency in contrast to static systems. When considering apartment buildings, one can conclude that energy consumption directly depends on the efficiency of HVAC systems. If we consider a high-performance facade, it is the exterior building envelope, which has properties such as the minimum amount of energy consumption to maintain the comfortable characteristics in the indoor environment. Energy efficient building should not only maintain comfortable conditions indoors, but also protect the building from the external environment. These building envelopes have certain properties which are present in figure 1. Energy efficient shells include an adaptive building envelope which has the ability to control various required characteristics, including changing its properties depending on change in the environment or depending on change in the indoor environment. Change in properties are achieved in various ways by introducing air flow, moving components, etc. The adaptivity systems can be divided in three categories. Category smart materials. As the name suggests, these materials which characteristic can be changed under the influence of change in external factors, such as change in temperature, change in electric or magnetic fields. In this case, materials that change their characteristic under the influence of heat, light, or moisture are used. Such materials used in high-performance facade include aerogels, solid hydrates, thermochromic polymer films, etc. Next category is smart building shell. This system is intelligent and independent. It takes into account weather fluctuation and makes a property change accordingly. This is achieved by building automation and physically adaptive components, intelligent prefabrications, sunshades, etc. And last system category is adaptive facade system. Adaptive facade system has the same characteristic as the smart building shell. This system, also like the smart building shell, includes real-time measurements, intelligent materials, human ability to make change independently. The distinguishing feature is of this system from the smart building shell is the use of computing algorithms that allow the system to adapt to the changing environment and provide timely information to the resident about its change and energy load. The residents are provided with information about the change of environment conditions. Terribly, they can adjust the living conditions depending on the climatic and energy load. Functional adaptive facade make it possible to design a new generation of buildings with nearly zero energy consumption. Adaptive building envelopes can be considered the next milestone in facade technology. In recent decades, there has been a powerful input in the development of adaptive building envelopes due to the integration of smart materials into adaptive building envelopes. Advanced adaptive structures in terms of energy consumption can be distinguished such as integrated facade, smart window, dynamic solar shading, fast change materials, and multifunctional facades. Adaptive facade system can be divided into dynamic facade, homogenic facade, adaptive solar facade, and active ventilated facade. Um, Dynamic facade. In this type of facade, the moving parts are activated automatically using built-in sensors that respond to change in the weather, time to day, etc. It is also possible to activate them manually. This facade allows you to control the microclimate in the rooms, for example, cooling during the warm season or thermal insulation during the cold season. Chromogenic facade. This facade includes such types of glazing as electrochromic glazing, liquid crystal glazing, and thermochromic glazing. In this type of facade, the glazing changes its degree of transparency, thermal conductivity, as well as the coefficient of light transmission depending on various factors. And adaptive solar facade. There are several types of facade with photovoltaic panels, bioclimatic facade, light concentrating facade, and double walled facade. Active ventilated facades. The essence of these facades is the ability to control air circulation in the building, so the distribution of airflow inside the cavities of the facade elements. It is also possible to control the incoming air in the building with the help of automated control of the glass elements of the building.